are in the final stages of this project that has been going on for about the last 16 months. Where we're at right now is this is our final public meeting, and we are really encouraging the public to come out and provide input either this evening or please visit our webpage, and we'll give you that address a little bit later on. But the public's input into this process is very, very important to us. So where we're at is this is our final public meeting. We will then be soliciting the input from the public and incorporating that into our current plan report that is under development. So I'd like to take a few minutes just to kind of walk you through the improvements that and recommendations that we've come up with over the last 18 months. And a lot of these improvements have come through a series of meetings that we've had with various stakeholders, including the public agencies. It's come through the public input process, and it's also come through some pretty thorough analysis and evaluation that we've conducted using some of our traffic engineering toolbox. So I'll walk over to the board that shows an overview of the improvements that we have come up with. So we started out with a very long list of improvements that probably exceeded somewhere in the neighborhood of 30 or 40 different alternatives. And we narrowed that list down through the public and stakeholder involvement process and came up with 3 sets of improvements that we're currently recommending. And those 3 sets of improvements include what we're calling active traffic management. And the active traffic management would occur along the entire corridor. Our corridor is at the south limits, Beltway 8, extending up through past the I-10 or 610 interchange, and then ending at the 45 interchange. And so active traffic management would be incorporated along that whole corridor. The second improvement that we're recommending is access modifications, and those are at specific conflict points along the corridor where we have high incident or high accident locations or bottlenecks that are occurring. And then our final set of recommendation is what we're calling managed lanes or HOV, HOT lane modifications. So I'll start with the active traffic management and walk you through those improvements to give you a better idea on what we mean when we say active traffic management. So active traffic management is actually giving us the ability to dynamically manage traffic either during congestion that occurs during peak periods or when an accident happens along the corridor, a crash happens. And what's different about active traffic management than what you see out along the corridor today is through devices and through sensors, we're actually collecting information and adjusting our traffic management strategies real time based on what those current conditions are. And then it's also even looking forward and based on previous traffic patterns that have occurred, beginning to predict some conditions that might happen and implementing strategies before those incidents even occur. So it gives us a whole new level of traffic management. The way it works is we would be deploying devices along the freeway, along the main lanes. These are signs that would be mounted above each of the travel lanes, the general purpose lanes, and these signs are high resolution full color matrix signs that would allow us to post a variety of messages on them. The ones that you're looking at here are showing how we would control speeds through advisory speed plaques. We also have the ability to open shoulder lanes. If an incident occurs along the main lanes, we can open up the shoulder for a temporary period to allow traffic to bypass the incident that way. A lot of the incidents that occur along the corridor cause congestion along the corridor, and so one of the strategies that we want to deploy is what we call queue warning. And all queue warning is it's alerting drivers to a slowdown along the main lanes before they come up upon it traveling at 40 or 50 miles per hour. So through the use of these signs, we would be able to control traffic and advise them that there's an incident and that they should begin to adjust their travel speeds before they get upon that incident. And what that would result in is the secondary collisions that oftentimes occur. The other thing that we would be doing is using adaptive ramp metering. Now, ramp metering is currently used along the corridor. There's traffic signals or traffic lights that are on the ramp locations, but we would be deploying a different type of operational strategy where we're looking at upstream and downstream volumes and adjusting the rate at which traffic can enter the main lanes based on what those volumes are. And that would allow us to keep freer flow along the main lanes and meter traffic off from the frontage roads onto the main lanes so that the congestion and backup doesn't occur. The other part of this active traffic management strategy that's really important is the ability to work with intelligent traffic signal controllers at the frontage road intersections and also along the arterial street intersections. And so these traffic signals would all be connected with each other and then also connected to the sensors on the main lanes to help us understand what is happening along the main lanes and allow us to adjust our traffic signal timings in a fashion that would better accommodate the traffic that might be exiting. So that's active traffic management. The neat thing about the active traffic management strategy is that it's one that can be implemented very quickly. There's been a lot of strong agency support for this. There seems to be a lot of public support for this. Relatively speaking, it's a lower cost alternative and is one that could probably be implemented within the next 3 to 5 years.